Welcome back. In our previous lesson, we started with the concept of compensating and equivalent variations. We mentioned that compensating variation is the amount of money by which an individual will need to be compensated for a price change to remain at its initial level of utility. An equivalent variation is a change in income that is equivalent in its effect on utility to a change in the price of a commodity. Now, in our previous lesson, we looked at a graphical representation of compensating variation. Today, we'll be moving on to a graphical representation of equivalent variation. If we go back to our consumer named George, who started from an equilibrium point E1 on indifference curve U1. In our previous lesson, we saw that an increase in the price of good X will move George to a new equilibrium point E2 on indifference curve U2. Now, the concept of compensating variation was to keep George on indifference curve U1 despite the change in price. To do this, we had to compensate George with enough income that brings him back to his initial level of utility. In today's lesson, we'll be assuming that, unlike compensating variation, George in this case wants to avoid the change in price so much that he does not mind losing money, which will move him from a higher indifference curve U1 to a lower indifference curve U2, as long as the relative price remain the same. In this case, George's main aim is to keep the price of X unchanged. Now, the question here will be, how much money would George be willing to give up to keep relative prices unchanged? The answer is exactly the amount that he would have lost if relative price changed. This is the whole concept of equivalent variation. On our diagram, to find the equivalent variation, we will have to move the original budget line towards the origin in a parallel fashion until it's just tangent to the new indifference curve U2. Now remember that the original budget line represents the original relative prices. The amount by which budget line B1, which is the original budget line, has to be shifted down until it is tangent to the indifference curve U2 is the vertical distance E. This vertical distance E is the equivalent variation of the price change. The new budget line that we get from this process is BE, and you can see that BE is just tangential to the indifference curve U2, and then there's a new equilibrium point here, EE. George has lost some utility because he moved from indifference curve U1, which is a higher one, to a lower indifference curve U2, but relative prices are the same because the budget line B1 and the budget line BE are parallel. Since B1 and BE are parallel, it means relative prices are the same. However, George had to sacrifice the vertical distance E to keep relative prices constant, moving him from indifference curve U1 to indifference curve U2. Hence, the new equilibrium bundle EE here will be on budget line BE and indifference curve U2. The next thing we are going to do is to compare the concept of compensating variation and equivalent variation. We know that George started with an equilibrium point E1, and the change in price of good X moved him to equilibrium point E2. We mentioned that to keep George on his initial utility, despite the change in price, we'll have to compensate him with an amount of money. And this amount is what we found as our compensating variation. This is the vertical distance between the budget line B2 and BC. We also mentioned that if on the flip side, George is happy to lose some level of utility, but all he wants is to keep relative prices the same, then he has to be willing to give up an amount of money for this to happen. The amount of money that George will be willing to sacrifice to keep relative prices constant is equivalent variation that we have found here. Observe that the compensating variation and the equivalent variation are not equal. The compensating and equivalent variation provide different estimates of the monetary value between the two indifference curves. Now, the two measures are different because they evaluate the welfare change in terms of different sets of relative prices. The compensating variation determines how much income, given the new prices, is required to compensate for the change in price. This is reflected by the fact that computing of the compensating variation involves shifting the budget line B2, whose slope is determined by the new price ratio. Now, on the other hand, the equivalent variation determines how much income would have been taken away at the original prices to do equivalent damage to the consumer's welfare, as does the price change. Now, finding the equivalent variation involves shifting budget line B1, which is the original budget line, whose slope is the initial price ratio. This is all that we have on our lesson on compensating and equivalent variation. Our next lesson will be looking at practical questions on this concept. If you enjoyed today's lesson, consider subscribing. Thank you.